It's really great to be here today, actually. It's fabulous to be here at Warwick University. It's great for me personally. I was actually born and bred in Coventry, and I actually went to school at Finham Park Comprehensive, which is about a mile and a half from here. So I know one or two of the speakers this morning were complaining about the challenges of driving around Coventry Ring Road. Well, some of us learned to drive on Coventry Ring Road, and it set us up well for the future. Some of us, when we were at that sort of age, also had the fabulous opportunity of living next to the university, being 6'3", which meant it was relatively straightforward to get into the student union bar as well. So that was all good. So, okay, what am I going to be talking about this morning? So what I really wanted to do was to highlight to you some of the things that maybe some of you weren't aware of with Autodesk. Autodesk has a fabulous history in the design space, supporting companies right the way through from the construction, architectural side of the business, through media and entertainment, through into product design and manufacturing. But over the last couple of years, there's been some significant changes in the organization, and I want to show you some of the projects, some of the activities that we're working on to really help organizations as they go through this disruptive period with rapid change in the manufacturing sector. So what I'm just going to do is to start with a short video, and we'll take things from there.
We are unique in what we do here. I've never seen anything like this before.
People come to us with challenges and problems where typically they don't know how it's going to be done.
Here within Autodesk Technology Centre in Birmingham, we make the impossible happen. We work with real organisations around the world who have these manufacturing challenges today. They need to get parts produced. They need to take advantage of new manufacturing technology.
We're working with a huge spectrum of customers in all kinds of different fields. It's a very dynamic problem-solving environment. Some of the coolest things we've done we aren't allowed to talk about. Some of the most impressive customers we're not allowed to name.
We might have an automotive customer who's maybe got an urgent project that they're working on. We get involved with a huge variety of aerospace projects and activities where organisations are developing new manufacturing processes.
We have got AS 9100 accreditation, which is a quality assurance for aerospace. So again, we are serious about manufacturing here.
We have 5-axis machine tools, mill turn centers, we have robotic solutions, we have machines which can do high-rate deposition for additive manufacturing. We even have hardware platforms which enable us to combine additive and subtractive on a single device. We work with customers who have challenging problems to help them develop the new manufacturing processes to enable those organizations to make anything.
I'm proud to have been a part of the redevelopment of this facility over the last 12 months. Autodesk has invested heavily in this facility, which I think reinforces their commitment to manufacturing. The future's looking good.
Autodesk reopened the Advanced Manufacturing Centre in Birmingham after a significant investment. Autodesk invested millions of dollars in the fabric of the facility, as well as millions of dollars in the equipment within the facility. All of it to help us, to help our customers to imagine the future of making things. We have a huge variety of hardware platforms there, from very large 5-axis machines, which we support customers in the automotive sector, for example, on developing new processes for the manufacture of tooling. We have large machines, ideally suited for projects to produce very large aerospace components, such as blisks, so components up to 2 meters in diameter, so very large components. We also have a range of robotic platforms, which we're using for capturing digital information, for subtractive processes, for additive processes. And as you saw there, we also have platforms specifically designed to enable us to support both additive and subtractive in a single platform. So these are hybrid platforms. Now, the facility in Birmingham isn't the only one of Autodesk's advanced technology centers located around the world. As well as this facility in Birmingham, we have a facility in Boston in the United States, Toronto, out in San Francisco, as well as facilities in Munich in Germany and Kilsyth in Australia. Now, with all of these facilities, what we're really trying to do is to partner with our customers to understand their manufacturing challenges. We have customers who are coming to us with a particular product. They need to have the particular design of the product. Maybe they need to have the particular materials because of the performance they're wanting to get at the end of the exercise. But they may well not know how to manufacture that product, or even to design that product in a way that can take advantage of the latest manufacturing technologies that are available. So it's a really exciting opportunity for us to work with those customers on a full commercial basis to help them to develop those new manufacturing processes to produce parts and components. But just as importantly, it informs us on the direction that we need to take our products to support both manufacturers at that bleeding edge today, as well as the broader organizations who are looking to adopt new manufacturing technologies and new design approaches into their businesses. Now we can see that the products that we're all involved with are radically changing. So there are opportunities to introduce new components. This is actually part of an automotive cylinder head. You can see within the center of it a completely different approach. So we've got lattice structures in there, both to lightweighten it, to improve the cooling performance of that product. But the challenges are about how we actually take that from the design through to manufacture and introducing it. And these are the types of challenges that our customers are wanting to take advantage of today. But when we think about where we've come from, if we just take a step back, if we think about the technology that was available for manufacturing, it doesn't take us very long to step back and think about some of the tools. Certainly, when I did my apprenticeship at British Aerospace a number of years ago, you know, the first thing that we were taught how to use was simple manual milling machines, manual lathes. Now, in reality, those devices, yep, they were great at producing those types of parts, but we were really, really limited in what we could produce. You know, a milling machine, it enables us to produce something that's effectively sort of fairly flat and blockish. We can maybe put some steps in it. And clearly, as product designers, what we recognized is we needed to produce lots of components and bolt them together because these were the machines that were available. Now, clearly, technology moved on, and as we saw the introduction of CNC machines, this began to enable us to automate manufacturing processes, reduce the number of components that were involved, and fundamentally begin to free us up in terms of a design process. So we were able to produce things which were relatively more complex than what we were able to produce in the past. But still a great deal of limitation in terms of what the technology that was available enabled us to manufacture. Now, we've been working with a partner in Europe, MX3D, who've had this really inspirational vision of how to go about producing, in this case, a bridge over the canals in Amsterdam. So they've really broken free from that initial constraints on their design imagination that you saw with a conventional milling machine, even if it is an advanced CNC 5-axis or mill-turn machine, freed their imagination as to what the actual design they'd really like to produce, and then asked themselves the question, how are we going to make this? Okay. So Autodesk partnered with MX3D to look at what the technology was available and how we could apply that technology. So MX3D have actually used effectively 6-axis robots here, robots to enable them to lay down material to produce these very, very complex 3D forms. And they're still working on this project, and what we will see over the next 18 months is actually the bridge being built in Amsterdam. Now, there's a whole series of very creative, very free-form types of shapes and things that people can think of in this space. But this is a great example of how, by reimagining the manufacturing processes, we can actually reimagine the design of many of the components that we're involved in today. So I'm just going to show you a short video of another project that we're involved with, which really takes this on to the next stage.
We build large vessels, big components. Our customers often keep expensive spare parts on the spot. They need them when parts fail. We want to help them having a look at their stock to see if we can reduce them. I see a big benefit for additive manufacturing to create added value.
I suspected it would be difficult, but let's go out and actually do it and make that big part. And see what we face and see the problems and solve them.
If it fails, well, we'll try again. From idea to and actually builds parts was very quick.
We realized this project in less than a year, which is really unheard of compared to other joint industry projects.
We're pushing the boundaries of what is possible. Actually go to that world where we have digital manufacturing, on-demand parts, and it needs to be certified, otherwise nobody will use it.
Additive manufacturing will be a big step forward, bringing designs into reality.
It's a really interesting project here, the RamLab project, which we've been doing with the Port of Rotterdam. The really interesting pieces about this project are we've taken a component right the way through from the beginning process, right the way through to having a class certified component. So that component has been both additive and subtractively manufactured. It's been approved for use on a commercial vessel. It's actually been put onto a commercial vessel and has actually been run for a period of time on that ship. So we've really proved out the technology in a very heavy engineering environment for very large-scale metal additive components. So to put that into context, that component weighs over 400 kilos. It's made from a bronze alloy, which is required because its operating environment is obviously seawater, which is particularly corrosive, a particularly unpleasant environment. So we've laid down a very large component, we've laid the component down rapidly, we've achieved the necessary finish, and we've proved it into production. So really taken that project right the way through. Now, the other thing that's really interesting about this project is the hardware that we're using is production off-the-shelf hardware. So it's effectively a welding robot. We actually have one at the facility in Birmingham, which we have configured for working in steel. That was our development process. The one at the Port of Rotterdam, specifically configured for running in bronze alloys, because that works quite effectively. And we have aerospace partners who actually have their machines specifically configured to run in titanium. The reason we don't do that in Birmingham is you have to run the titanium machines in an inert atmosphere. And every time you open the door of the machine, you kill everybody on the shop floor. So we don't do that in Birmingham. We let the aerospace guys do that in specific facilities there. So we're using production-ready hardware. We're able to take it right the way through from conceptual design to a finished component today. And just as importantly, the software tools that support these manufacturing processes are actually released on Friday this week. Okay? So we have the full capability and are able to demonstrate the capability and deliver the capability for organizations who want to take advantage of the opportunities that this type of process provides. Now, going back to the start of the video, they didn't mention in the video, at the Port of Rotterdam, the reason they're really interested is a large container ship, you know, the things that enable you and I to get our products around the world and enable us to get access to the huge variety of products we all rely on today. The cost of having a large container ship in port is estimated today at $250,000 a day, which is okay if that's part of your production schedule and it's there to get the containers off and get new containers on and move around the world. That is a terrifying number if the reason that your container ship is parked in the port is it's got a breakage, it's got a broken component. Okay? So clearly, if you've got a broken component, you're going to need to rapidly get a replacement part onto the ship. But if you were going to take a component like that one, you probably needed to order it from the manufacturer. It could take some weeks to arrive, as it's probably been produced somewhere else in the world. Or if it's actually going to be made and you casting produce, it could actually take some months. So when you begin to look at technologies like this, the ability to just-in-time produce parts, replace what actually happens today, which is a huge stock of components, there's a great number of opportunities to radically improve what we do today. Right, so maybe going on and looking maybe more in sort of some of the precision engineering areas where I'm sure many of you are involved. This is the Lightning Motorcycle Company. So this motorcycle is interesting in a number of ways. First one is it's actually the current world record holder for the fastest production motorcycle anywhere in the world today. So that's fabulous in its own right. It's even more fabulous when you realize that This motorcycle is actually an electric motorcycle, so no internal combustion engine, electric motorbike, and yeah, the current land speed record holder for production motorbikes. Now, the interesting thing there, though, is that as well as having a unique drivetrain, they've obviously had to spend a huge amount of time looking to optimize all of the different components on that motorcycle. We're going to have a look at a little bit of a case study of one of the components on the motorcycle, which is actually the swing arm on the back of the bike. So you can see we've actually taken the swing arm off here. We've actually got the geometry of the bike, and what we need to do is to work out what is the optimized design. And there's a whole series of different things that we really need to take into account when we do that. So the first things we've got to do is we've got to identify what are the features that are really, really important to us. What are the things that we want to keep? We also then need to identify, in terms of this design, if we're looking to generatively produce a component, what are the things that we need to take into account? What are the areas on the model that we can't have impacted by our generative design? What are the stresses, what are the loads that are going to be on the component? But also we want to take into account what are the manufacturing processes that we're going to use. Obviously radically different if we're using an additive process, a subtractive process, maybe we're using a casting process. And what we can do is we can use our generative tools to identify a whole series of different solutions, and then we can select from that a range of solutions what's the most appropriate solution given the particular design requirements we have. We can take into account maybe when we want the part, where we want the part produced, to identify what is the most appropriate component for our particular design. So here you can see we've got our swing arm, we've got our idea as to what the design needs to be. And the great thing with this particular project, we've been able to partner with the Lightning Motorcycle Company and actually help them to develop some components. So you can see the swing arm here, we've got a generatively designed result. This particular item, typically, we could either look at direct metal additive, or we could actually look at using an additive process to produce something that we might sacrificially cast, burn away to give us our finished component. Now that's a fabulous piece of design there. Certainly it's a design that a designer is unlikely to come up with just using their own inspiration. So we've come up with something which has got a really unique set of performance parameters and identified by the system. But what's interesting here is we have given it the complete freedom to look at any particular manufacturing process. And effectively, that's fabulous if cost is not an issue. But clearly, in many applications, we need to trade off the cost of that production process with the actual finished design we've come up with. So we've taken this type of concept and we've said, okay, if we were going to use a machining process, now this is actually a different component, this isn't the swing arm actually on the bike, but going through a similar generative process and in particular coming up with a design which is specifically designed for a machining process rather than an additive process. So taking our original design need and then producing a generative design whilst identifying what our particular manufacturing requirements are going to be. And in this case, it was 5-axis machining. So just to sort of help people get a bit of a flavour for that, we've got a couple of props, so very Blue Peter style here. So I've actually got this is a design which actually, at the most extreme end, so we've used a slightly different process to generative here. We've actually just used a light weighting process. We have built a lattice structure inside to remove as much weight as possible for the component. In this case, we've actually used the subtractive 5-axis machining process to give us a component which is significantly heavier, okay, but significantly cheaper to produce. So what I'm going to do, I'm going to pass these around. If it doesn't come back, I'm going to be in big trouble, so please make sure these ones come back. And for the people who, when I came in with a little carrier bag earlier on and just put it underneath the stage there, I was expecting somebody to say I was doing something quite suspicious when I then disappeared off afterwards, but nobody seemed to spot that either. So I'm going to pass these around, and people can have a bit of a play. Put one in one hand, one in the other, and you get a bit of a flavour for the difference. Okay, so we've talked a lot about automation, and we've talked a lot about automation in the context of enabling us to really free up our creative juices, so enable us to do some far more creative things. But automation also gives us some fabulous opportunities to eliminate some processes which are at best unpleasant and in some cases actually downright dangerous. So one of the other areas where we actually have some research going on at the moment is in polishing processes. So some of you will appreciate that lots and lots of manufacturing processes today contain polishing, okay? Those polishing processes are actually typically done by hand today. They're often dirty, they're unpleasant, and in many cases in the Western Europe, there'll actually be processes which are banned. You know, a number of organizations have come up with a cunning solution of why don't we get it done somewhere outside of Europe. But a much better approach is to say, what is it that we're trying to achieve in terms of polishing our components? How can we use the latest technology in terms of robotics, surface analysis, to enable us to replace these manual processes with much more automated processes? But just as importantly, how can we involve the operators in these processes to enable us to use their knowledge and experience? So here we're using augmented reality along with processes to drive the robotic solutions for polishing to enable us to ensure that we are getting the results that we want to achieve today. So really interesting combination of both automation as well as augmented reality to provide a unique solution to people. So where do we go next? Well, one of the most important things really is to bring this together. We've looked at various new pieces of manufacturing technology which are available today, but clearly organizations need to stitch those pieces of technology together. As we move to an era with much more mass customization, much more production local to where the customer is, what we need to be able to do is to make it much more automatic for people to manage the supply of information from their design systems out to the machines onto the shop floor, capturing the information about what is really going on the shop floor, driving that back to really control our manufacturing process or to inform our design process. And so what we're introducing is another series of technology called fusion production, which enables us to manage the information as it's created and sent out into the factory. So this is one of our customers, KPM Motorsport. They produce drive lines for high-performance motor vehicles. So having produced the instructions that they got for the machining of their component, they can obviously send that down onto the shop floor and provide access to their operators. But with fusion production, what they're able to do is to identify which of the machines on the shop floor they want to drive, provide that information out to the operators on the shop floor. But if there are changes, so for example, changing which machine we're going to be operating, we can quickly send those instructions to a different machine. We can ensure the operators are actually following the instructions that they've been provided, so sharing the information with them either via their phones, their tablets, to ensure they've got the latest production information that they require, whilst continuously feeding all of that information back to the process engineering team or back to the design team, either to make changes to the products that are being produced or to inform our manufacturing decisions. So for example, if we sent it to machine A because we believe machine A is going to machine the part in half of the time, but what we actually discover is that as we look at a whole series of jobs that the machining performance of that machine is actually slower, it may be that we want to select a different manufacturing process. So by capturing all this information, we can ensure we are making the best use of our manufacturing facility. We're able to rapidly change when we need to make changes to our manufacturing facility, or we can use it to feed back information back to our design team. Okay, so that has very much been a whistle-stop tour of where we are today. One of the things I wanted to highlight about directions we're going in for the future. We've looked a lot actually at additive processes, mechanisms for taking advantage of high-rate deposition techniques to enable us to produce components. But one of the projects we have underway is actually taking this technology and placing it inside a shipping container to enable us to move our manufacturing facility, whether that's exclusively doing additive or both a combination of additive and subtractive processes, and actually taking it to where the work's required. Now that could be something as simple as taking that container and putting it into a business park somewhere else, because that's where your customers are going to be. Or it could be as extreme as taking that shipping container and taking it maybe out onto a construction site to enable you to produce that one-off bracket or to fabricate that one-off component that you need for your structure. So this is a project we have underway at the moment, and this shipping container will be ferrying its way around the world to various locations in the coming months. So I think without any further ado, if anybody has any questions, I'm more than happy to take them now, or if we're a little bit tight on time, people can grab me at coffee or lunch. Okay, thank you.